tool lets you know it's chattering by vibrating the drawbar wrench onto your foot. Hello Internet, my name is Quinn and this is Blondihacks. Today I'm going to make a cross-drilling fixture. This is a really useful thing on both the mill and the lathe that allows you to do really precise and repeatable cross-drilled holes in round stock especially. It's a very useful thing to have around and it's a great intermediate level milling project. So let's go. Here's what I'm going to make. It's essentially a V-block shown in pink there with a hole down the center of it so we can drill through without touching it. And then in yellow is a clamp with a couple of big countersunk cap screws on either side to hold the round stock in place. And then there's some reamed alignment holes on the corners there, just in case it helps with a setup at some point in the future. Now there's another style of cross-drilling fixture you can make where the clamp is precision aligned with the base and then you use drill bushings to guide the drill. And that's a lot more effort to make, but it does save you needing to center drill before you drill your holes. I'm going with the simpler version because it'll do what I need, but those precision alignment holes in the corners could someday be used to extend this to be the other version later if I want to. Hey Internet, it's me, Quinn. We're friends, right? You seem like nice people. So let's talk about this, because if you know something about fixture design, you've noticed that this little slot is missing in mine. But what is that slot for? Well, here's an example of a V-block fixture that does not have that slot. And look what happens if I try to put something square in there. Should work, right? Square object, square slot. But it doesn't quite sit right. Wiggles back and forth a little bit. Doesn't seat fully in there. Same thing now on this guy. Rock solid. Why is that? Well, it's because in the real world, there's no such thing as a true inside 90-degree corner. There's always a little fillet down there. No matter how sharp your tool is, you can never get a tool perfectly sharp. So there's a nose radius on it. That nose radius creates a little fillet in the bottom of the cut. And that little fillet interacts with the corner of the block and keeps it from sitting properly down in there. Now for round things, it doesn't really matter because they don't interact with that part of the slot. However, it's nice to put it in there in case you ever do want to put square stuff in there, and I honestly intended to do that with my design and just completely forgot. So I've updated the models to include that slot, and if you get the drawings off my Patreon, it will also include that slot, and I can always add it later if I want to, but just keep that in mind as you watch the rest of this video that it's a good idea to have that in there. I've got a big chunk of 1018 mild steel that I'm going to make this from. Now, mild steel is not a great choice for a precision fixture like this. It would be much better to use something like tool steel, but this is what I have, so I'm going to make the best of it. Now, how do you make a precision fixture when you don't have a surface grinder and all you have are cheap Chinese machine tools? Well, I'm going to show you some techniques for achieving precision in such an environment. So I've cut two nice chunks here to make the two parts of the fixture out of, and I'll deburr those saw cuts. And now I'm going to find the right size parallels to set it up here in the vise. The secret to success with cheap machine tools is to understand where you need precision and sacrifice other areas in order to get it in those areas. And I'll show you what I mean here shortly. I'm going to tap this in. Now one of the areas where I need precision is surface finish because the surfaces of this fixture are going to be used for indicating and edge finding and so on. So for that reason I'm going to be fly cutting everything. So the first cut is easy because it just needs cleaning up with the fly cutter. Now I say this every time I use the fly cutter, but I'm still somehow amazed every time I use the fly cutter at what kind of results you can get on surface finish. I mean, this is mild steel, and the result is just outstanding. Fly cutters really are magical, especially on really low rigidity machines that struggle with surface finish on something like mild steel. So with that surface cleaned up, I can now put it against the fixed jaw, and I've got my soft copper wire in there to take up imperfections on the movable jaw on the unmachined surface, and I'm going to fly cut the second surface. And this is going to give me two surfaces with excellent surface finish and very, very square to each other. Now the first side is easy to fly cut because that's a factory finish. This is a saw cut, however, and this cut started to get too deep because the saw cut isn't as square. So I had to stop and lift the cutter up a little bit touch off again in a new spot, and now I've got a little bit of a stair step. So now I can go back to the lower spot and go down a little bit more and cut again, because you can only go, 5 thou deep probably max with a fly cutter. And so this way I can kind of work my way down, and then once I've got one pass that's clean, I'll do one more light pass to get the best possible finish. So plan for that if you're going to be fly cutting. You don't want to do too much material removal. Now I can take that real nice square corner and put it down and back up against the fixed jaw, and that's going to be our reference moving forward. Now I have to bring it down to dimension, and I have quite a bit more material to remove here, so I've switched out to an end mill where I can take deeper cuts. So I can do a 20 thou pass here. I need a lot of little passes here, of course, because it's a small end mill, but I'll only need to do one cut here, and then I can come back in with the fly cutter to finish it up and bring it to final dimension. And that's not an accident. I designed this part around the stock that I knew I had. So a quick check with the mic to see how much I need to fly cut to finish it off. The goal here is, of course, to land within 5 thou of the final dimension so that the fly cutter can finish it up. This parallelogram fly cutter that I made always looks like it's bouncing up and down. I love this thing, but one of these days it's going to put a high-speed steel cutter into my face, or the floor, or my face, or the floor. The reason the fly cutter is shaped this way is to balance the mass. I've got a video on the theory and making of this fly cutter on my playlist, so go check that out if you're interested. And between all these setups, I'm of course deburring all of the cuts to make sure that the burrs don't interfere with how the part sits in the vise, as is practice with squaring up stock. So final check with the mic there, and that's looking good. So now I have a U shape that's all finished. I have one short side left here to bring down to dimension. Once again, I did the rough work with an end mill because I had a fair bit of material to bring it down to size, and then I fly cut the result once again. Final check to see how I did on dimension, and I can move on. So now I have a ring of finished and square faces around one axis of the part, but now comes the hard part. For the other two sides, we have no reference for squareness on the x-axis. So I have to bring in the indicator and square up one of the machined faces that we've just done. And that's not particularly square, of course, because it's sitting on an unmachined surface on the bottom there. So I'll tap this in, and I'm using my finger to create a fulcrum on the back corner there, because otherwise when you tap it with the hammer, it tends to just slide in the vise. So just putting your finger in the base makes a hinge point so that it will tilt instead of sliding. And we are within a couple of tenths there. The vibration there is a combination of the gearing in my mill and the surface finish not being precision ground. This surface can now be fly cut. And now we just have one surface left to do, and this is pretty easy because now we have a machined surface opposite it, so we can just seat it down in the vise and bring that down to size with the mill and or fly cutter as before. This is a very nice block, but we actually need a V block. So how do you make a block into a V block? I think you put a V in it. So I'm going to lay it out here just as a sanity check, but ultimately we're going to be using the DRO to get this in exactly the right place. And I'm also going to transfer the V to the side using this rather unfortunately shaped non-family friendly tool. And that is going to be a nice guideline, so we should be able to see the end mill line up on that if we're doing everything right. So I'm going to set it up in the vise, and I'm going to just clamp it at a 45-degree angle. I've got a stare at 45-degree angle block there that's going to set this up. And then I can just double check and make sure there's no rock there. If you had a sign bar or something like that, that would be a more precise way to set this up, but I'm gonna have to use the angle block. The secret to this technique is that we're using the squareness of the end mill itself to create the perfect V. But that does mean we have to mill the stock at this funny angle, and that also means it's a little tricky to get the center of the V to land in the right place because we're milling the hypotenuse of that triangle. Now we can easily find this top edge by touching off with the end mill, so what we need to know is this distance here. How far down do we go so that we're milling the bottom surface of our V there, and then the side of the end mill is going to create the other surface of the V. Well, we know this hypotenuse distance, of course, because we know the width of our V slot and the size of the block, and it's centered on the block, so that's easy. And because this is all 45-degree angles, the right triangle that we're forming is isosceles, and so all of the other sides are the same dimension. So grade school trig, a squared plus b squared equals c squared. A and b have the same value, therefore to get z, we square c, divide by 2, and take the root of that. Finally, we need to know how far to mill on X. For that, we have another little isosceles right triangle in the V slot there. The depth of the V is the same as half the width of the V, so the X milling distance is just the V slot depth squared times 2 and square root of that once again. I don't actually want to touch off with the milling cutter on my block and risk messing it up, so I'm going to use a feeler gauge to find that corner. This is a 10th thou feeler, so once I've found that gap, I know I can just move down 10th thou and my cutter will be right on that corner. Now note that that corner is ever so slightly chamfered because it was deburred, and so there is going to be a little bit of error here, but I'll show you how to deal with that in a moment. Now we translate down the amount we calculated, and if we did it right, you should see the edge of the cutter line up right on our layout line, which it does. Now we can start making passes, and we're translating only on the X here. Now, a Bridgeport could probably do this in one pass, but this little toy mill cannot. So I'm doing 20 thou passes here. The trick here is that side milling is what's doing all of the work, and as we get deeper into the V, of course, that depth of cut gets bigger and bigger. There's more and more material on the side of the end mill there. So you may have to do lighter cuts as you get deeper into the V. If you really had to, you could also raise your Z a little bit and do 2 passes, but I would really try to avoid that because you're going to mess up your very carefully created bottom surface there. So the most precise way to do this, if you can, is to just don't touch that vertical height at all for the entire operation. And I was able to do it with 20 thou passes. I think I did a couple of 15 and 10 thou passes at the end when it started to get really heavy. And then for the very final pass, I also did a spring pass on the way back just to make sure that the V ends up exactly where it should, as according to our calculations. So it looks nice. Now, the real question though is it in the right place? It's really important that this V be very well centered between the sides of the block because I want to be able to use it for edge finding to find the center of the material that's sitting in that V. So to check that, it's over to the surface plate. I've got a gauge pin clamped in the V there, and I'll just measure the height here. So I slide this in under the indicator until I find the high spot, just whatever's the highest reading there. And then I zero the indicator right there. Make sure that's on 0, and then now I just flip it over and measure the other side, and whatever the height difference is tells me how far off of center the V is there. And survey says it is 4 thou off center, and that's because of that chamfer that I mentioned. Remember, the chamfer caused my end mill to be a little bit lower than strictly where the physical corner of that block would be in a perfect world, but that's okay. I can just fly cut 4/1000ths off that side. This is back to what I was saying, how you have to know what precision is important. The actual dimensions of this block don't really matter. What matters is that the surface finishes are good and that the V is centered on whatever size the block is. So after that cut, we're now within 1/10 or so of being perfectly centered on that. So that's an easy way to achieve precision on low precision equipment like this. Adjust the unimportant dimensions to suit wherever the important dimensions happen to land. Time to drill the hole through the center now, and it would be tempting to set it up like this and drill from above because then I can see what I'm doing and I can chamfer easily, but that's not going to work very well. When the drill encounters that V, it's going to want to get pushed along the length of the V. Even if you pilot drill, when you come in with a larger drill, the tip of the drill can't engage the pilot hole before it hits the V, so you have the same problem. So potential for shenanigans is high there, so instead I'm going to do all of these holes from below. Drill it from the underside, and then it's going to break through into the V, but in a way that isn't going to deflect the drill. Now getting this hole perfectly centered is super important. I want it to come through right in the middle of that V, so I'm edge finding twice on each edge just to double check the measurement on the DRO, and I'm cranking around the part to get to each side. I'm not lifting the quill up and over. That way all the readings are done with the quill locked in the exact same position, and there's no chance of quill deflection causing error. From here, it's a pretty straightforward drilling operation. Of course, I'll start by center drilling it to keep the drill on target. After all that work to find the center, I don't want the drill to have its own ideas about where center is. And I'm going to start with a pilot drill. And this just goes all the way through without drama. Now, of course, it does sound and feel a little funny when it gets into that V at the bottom, but that's what we expect. But luckily, because we're drilling from the bottom, there's no deflection. And I'm going to go up in a couple of stages to my final size. Again, going up in smaller stages means the drill is doing less work, less chance for deflection, and the mill is also not working as hard. Once I get up to the larger sizes though, I have to remove my drill chuck because I don't have enough Z height on this little mill, and it's time to use the collets. Now you can put drills in collets, of course. The catch is you have to have collets that are the size of the drill, and drills come in a lot more sizes than collets do, or at least normal collets. So I can go up a couple more sizes here. The final size is going to be a 1/2 inch drill. I would have liked to have reamed this, but in order to do that I have to drill 1/64 under 1/2 inch, and I don't have a collet that size, so instead I'm just going to drill it, which is fine. This doesn't really need to be a precision hole anyway. It's really just a clearance hole for drilling operations that you're doing in the fixture. If I did that right, that hole will be perfectly centered on the V, and the edges of the hole will meet the V right at the top. And I'll get a little preview of that with the inspection mirror, but you will have to wait. But it looks good. I'm going to put a light chamfer on there with one of my favorite tools. This is a zero flute chamfering tool. It's called zero flute because it doesn't really have a cutting edge on it. I mean, it does, but the cutting edge is formed by a cylinder that's punched through the cutter at an angle. What that does is it creates a very progressive cutting edge that basically is immune to chatter. It's very cool. The limitation of them is that they have a very narrow size range of holes on which they work. So you have to have a whole bunch of sizes of them, but they do a really beautiful job. Now the center hole there is my reference, so from there it's an easy job to center drill the 4 alignment holes. However, unfortunately, my parallels are in a bad spot. This happens to me a lot. I put the parallels in there not thinking about where the holes are going to be. So I can work around that thusly. So I'm drilling the holes not all the way through, and while I'm here I'm also going to put in the tapping holes for the bolts that actually do the clamping. Those are going to be drilled all the way through from below as well. So now I can pull the part out to adjust my parallels. The good news is the relationship of these holes to the center isn't that critical. So redoing this setup will cost me a few thousandths of alignment, but it's not going to hurt anything. So I'll tap that in with the parallels in a better spot, and now I can come in with a 1/2 inch gauge pin and locate that hole again. That hole was drilled though, not reamed, so it's not as precise as a reamed hole would be. A reamed hole would get us probably within 1/1000th doing this trick, but because it's a drilled hole, we're probably just within a few thousandths, but again, it'll be good enough. And since I already pre-drilled them most of the way through, the drill is going to find the old hole anyway, so I can punch those all the way through and then finish up reaming all 4 of them. And these alignment holes are just kind of a future-proofing thing. It's never a bad idea to have precision alignment holes on a fixture. Someday in the future you can put an alignment pin in there, you can pin it to a fixture, you can use it to bolt it to the faceplate on the lathe, or, never hurts to have precision mounting holes and things. And I'll chamfer these as well using one of these smaller zero flute chamfering tools that I also have. Now to tap these, I chose 3/816 for these holes just because it's the same hardware that my strap clamp set uses for my mill, so you never know, and that might come in handy someday. I might want to bolt this to something involving strap clamp hardware. Again, just trying to maximize the options in which this thing might be usable in the future. The edge that results from the interaction of the hole and the V is quite complex, and so I had to resort to a 1/2 round needle file to deburr this. If you remember your conic sections in school, this is a tricky one. There's the final block. Not bad for a cheap Chinese mill and a drunk Canadian amateur. Onto the strap now. Once again, the block is squared up to start. I'm not going to fly cut this because it's not a precision alignment surface, but honestly, the end mill is doing a great job. It doesn't look as nice as the fly cutter, but it feels very smooth. The only thing of note here is that I cut the stock quite a bit too thick on one dimension, a mistake I often make, so I went in with a roughing end mill to bring that down to size, because I had to take 300 thou off of that. Again, a Bridgeport can do that in one pass, I suppose, but on this little mill, 300 thou is a lot of work. 50 thou pass is about as deep as I can go on a 1/2 inch width end mill. And to square up the ends this time, I just side mill because it's a small part, so this works just fine. Lengthwise, I just matched the block that I created instead of going strictly by the drawing because, again, I had made that block a little undersized to get the V nice and centered. Now my reference is once again the center of the clamp, so edge find on Y, 0 that, edge find on the other Y, Y1/2, edge find on one X, 0 that, edge find on the other X, and X1/2, and we're in the center. From here, a very straightforward set of drilling operations once again. The center hole is once again 1/2 inch and I'm drilling it, but if this was a precision style cross drilling fixture, you would want to ream this so that your drill bushings are well centered. So this would have to be done on the lathe in my case because I don't have space on the mill for that. Now to counterbore these holes for the cap screws, things are going to get interesting. Ideally, I would use a 5/8 end mill for this. I don't have one, but I did find a 16mm end mill, so that's close enough. This is kind of working, but the mill is really vibrating a lot and the cutter's chattering. It is unhappy with this. It's just too much material to try and remove at once. I don't know what I was thinking, especially with a 4-flute cutter like that plunging. So instead, I'm going to come back in with a 2-flute 1/2-inch end mill, and I'm going to use a feeler gauge to once again find the top of the surface there. You can see that the 2-flute 1/2-inch mill is cutting much, much nicer. It's very happy in there. Mill isn't vibrating anymore, so clearly this is much more within the realm of this machine's capabilities. Once again, if you've got a Bridgeport, go in there with the big end mill, you're probably fine. On this little mill, not so much. Now I can come back in with that 4-flute cutter. I'm using a 4-flute cutter here because it's the only one I have in this size, so it's obviously working a lot harder, and there is still some vibration here. It's really not a good use case for this cutter, but it did work after clearing out the bulk of the material, and actually the surface finish in there is really good except for the hole on the left, which has a bit of a gouge in it where the cutter was chattering. But that's okay, it'll be hidden by the bolt head, and I won't tell anyone if you don't. And as I always say, chamfers are what separate us from the animals, so I went around the outside edge with my 2-flute carbide chamfering mill. Last but not least, my favorite 0-flute chamfering tool, once again, make everything look nice and machiny. There's the final block. I'm pretty pleased with that. I think that turned out quite good. Now for finishing, the block is going to get cold blued, so I'm going to clean it up with acetone. It'll be a nice 2-tone contrast, I think, with the base that's going to remain bright finish. So for that, I'm using Jack's Cold Blue. It's not my favorite of the blackening products, but I have a bunch of it and I'm going to use it up. This stuff works well if the part is small enough to completely immerse in it. So I think it'll be good in this case. So I drop the part in there, let it sit for a minute, take it out, and then I rinse it off in water to stop the reaction. And the water should turn a sort of funny dingy brown. That's how you know it's working. And then dry that off thoroughly, and then coat everything with oil to seal that surface. You can use pretty much any oil for this, I think. I use Way Oil ISO 68. Seems to work really well. It's a nice durable oil that stays on the surface. And then you can wipe off the excess oil, and there it is. A little more wiping maybe, a little oil on there yet, but it's looking good. For the main block, I'm going to keep it bright finish because I'm very pleased with how it looks, and I'm going to use Bow Shield T9 for this. This is like a thin spray-on wax. It's great for keeping precision surfaces rust-free without altering their look at all. This stuff is a little bit expensive, but that little tiny can there is like a 10-year supply. A little of it goes a very, very long way. You just let that dry. And now let's give it a little test run. So here's the part that I needed a cross hole in, and it's a small part and it needs a very big hole in the middle of it, so there's really no good way to hold on to it. So in comes the cross drilling fixture. Bolt that part down there and over to the mill. We can set it right on the parallels, and we'll tap it down to make sure that everything is referenced correctly. And now the magic is we can edge find on the fixture because we know that V is very, very well centered on the fixture. Now for the ends, there isn't quite enough stock exposed to edge find on, so I'm just going to slide a gauge block in there. Now if the material that you're cross drilling was bigger, of course you could just edge find directly on the material, and that's fine, but one of the reasons I wanted this fixture was for working with really small parts like this, which is something I do quite a bit. And now I can come in and center drill so that the drill doesn't wander off of the convex top surface there. It's a little hard to see down there, but the inspection mirror tells me that the center drill is good, and now I can cross drill all the way through my part. And of course, this would be where you would use a drill bushing, and you wouldn't have to center drill if this was a precision style fixture, but that's not the one that I built. I happen to need a thread in this part, so of course I can still come in now and thread through that hole as well. So it's a cross threading fixture also. And there's our part. Hole perfectly drilled and threaded right through the center. As you can see, there was very little meat to hold on to, so it would have been difficult to do this any other way. The cool thing is this is of course repeatable on the y-axis, so if you have a bunch of these to make, which I do, I can put the next one in and I only have to edge find on the x-axis now. The rest of the setup's already done for me. So that is the final little cross drilling fixture. This was a lot of fun to make, and this is going to be super useful. This is something I've wanted for a long time. I keep finding times when I wish I had one of these, so there it is. I hope you enjoyed watching me make this. Drawings and models are available on my Patreon if you are interested. And hey, throw me a little love on that Patreon if you like these videos. And I will see you next time.